My name is Matias Piipari, and I'm indeed working for a company called Adipon. And I want to thank firstly for the opportunity to actually present here today. And the reason I'm presenting instead of Daniel Brown, who's actually done all the work that I'm presenting, is plainly Brexit. We were kind of worried that he would be stuck here because of yesterday having been the supposed Brexit deadline. Now, whether it's nicer to be stuck in Copenhagen or London right now, or especially in a few months, I'll reserve judgment with this tweet, but I'll get on with my talk. So, briefly, what I will cover today is a bit of background to this project and the product that we built, and some use cases and architectural details of it to then motivate the rationale that we had for choosing using Swift on our servers for some of the aspects of it. And some of the pros and cons and gotchas that we've hit on the way in this project. So firstly, probably none of you have heard what Adipon as a company is or who they are, but actually many of you may have actually used some of their products. Because what Adipon does is content management systems for scientific and technical publishers. So for example, if you've ever read computer science papers from the ACM website, that's actually an Adipon provided site. Also a lot of technical and programming content, kind of the online versions are served by them. But what I've been working on at Adipon is actually not content management related, but actually a scientific writing tool called Manuscripts, which I sold to Adipon a few years ago. And at the acquisition time, what we had available was this Mac application that looks like that. So it's basically an outline and a very familiar looking word processing tool that deals with stuff that is kind of scholarly in nature, things like citations, equation markup, code snippets, and kind of things that you need in technical, complicated documents. But the thing is that not everybody is sadly using a Mac, especially in scientific work is very collaborative in nature, and Mac users need to be able to collaborate with non-Mac users. So we had this challenge of turning this Mac application into something that you could collaborate and you could bring along people who are not necessarily convinced to install anything on their system yet. And kind of before I kind of get into the solution of that, I want to give a bit further back in time. So this project actually came out of a kind of a long-term obsession of mine whilst I was working it was a side project for me for good 4 years. I was writing this and my wife started taking these pictures of me coding this program in totally random places, like pair programming with my daughter up there, or pair programming with somebody who had passed out on the tube in one of the pictures. So this was basically evening and weekend work for a good 4 years, along with a contractor who was working with me in the project, whilst I was a CTO in a different software company. But kind of what came out of it eventually was this collaborative version that we've shipped some weeks ago. And so this is a browser-based version of the same stack with a very, very similar user experience, very, very similar underlying document file format and way of looking at what that document is. I'll really quickly just jump out of the presentation and show you one feature that I think you'll appreciate. So looks like a word processor, but what you're actually able to do with this as well is to actually create visualizations from code. So we're actually able to execute, in this case, Python or R or Julia code directly inside this word processor. And what we're doing this with is not, we didn't build this stuff ourselves. It's based on Jupyter, which is a computational notebook system that is used a lot in different kind of data science and scientific disciplines. But I'm showing this because a challenge in a project like this is that it's an integration piece to all kinds of complicated external open source things for citations and equations, and in this case, the code execution. And the other side of it is that what's really the point of creating a word processor at this point in time? It is plainly so that because scientific papers at the moment, kind of a lot of them follow this level of description of experiments, and especially if you looked at computational papers and computer science papers, machine learning papers that have some algorithmic component to it, often you're just subjected to this kind of pseudocode that kind of in very vague terms describes what you're supposed to be getting at the end result. basically the problem is reproducibility. And we want to create papers that, by being dynamic and interactive and having the associated data sets and code behind, will allow you to create more reproducible experiments, to be able to draw the rest of the down owl. And our solution, like I said, is a real-time collaborative environment for technical and scientific writers that deals with a lot of the document formatting, letting you focus on more on your story, and in part allows you to execute your document and its figures in it. Now, we created actually quite a sizable open source project out of this work as well as part of the last 2 years. So it's about 18 repositories, if I recall right, at the moment. So there's a separable editor component, there's various kinds of pieces to the synchronization and collaborative environment behind this that is publicly visible, openly available. And in terms of the layers in this stack, we've ended up with a couple of them. So there's this client applications at the top, so that we have an installable browser app for in case of Chrome. You can write also offline in any kind of web browsers, and then we've got these Mac and iOS clients that are the legacy of the old kind of side project stage of this project. And what's underneath that in the application client is an editor component, one for the front matter, as in the author list and affiliations, and one for the document body, and a data model and encoders and decoders for the different file formats that you have to be able to interoperate with, as well as this real-time collaboration stack. And what's at the back end is a collaboration and synchronization system as some access control, and finally document conversions. And this is where we get the Swift and some ugly engineering decisions that we had to make a few years ago. So this is what we wanted to build about 2 years ago. And as we started drawing these diagrams up, it became quite obvious that in order to ship anything like this in about 2 years with a team of 6 people at that stage, we would have to make some sort of compromises. And one of those compromises was perhaps, well, let's not rewrite everything, even though we perhaps would want to. And we realized that actually this document conversion part, the kind of I/O in manuscripts I/O, was a component that we could actually separate out from the Mac application that we already had and shove it inside a web service and keep running it as we focused on new parts of the stack. So what we wanted to do is ship this entire system, the 2-point version of it, in a year and a half with a team of 6. And we mostly made it. It took 2 years rather than 1.5, but that's not bad. And the challenge being, can we isolate into a web service something that existed in this manuscripts for Mac 1.0, dealing with document format transformations. Now, the reason we didn't want to specifically rewrite this part is because it's complicated. So things like Microsoft Word import or export are really nightmarishly complicated things to do right, and the only thing you really have is a sizable regression test suite to really trust that it actually works, even if you decided to rewrite it from scratch. WordML spec is something like 5,000 or 6,000 pages long. You don't want to read it. So it's really the kind of project that is supposed to fail if you start rewriting it. So we had these various output formats and input formats that we were already able to deal with. There's other acronyms that I won't really subject you to, but just to say, some of these file formats precede Unicode and the internet. And again, it's not something you want to really focus too much of your effort on if we want to also at the same time rebuild a really nice user experience in a collaborative setting. And finally, the service was also dealing with some fancy AI stuff for extracting metadata out of unstructured documents. What does that mean? Well, that means that if you throw in a Word file that doesn't have any kind of backing metadata inside it, we're able to extract things like author names, affiliations, title, automatically out of it to some degree. I mean, there'll be errors in it, but it does do that. And all of this is actually quite important in the publication process when a publisher receives a scientific document, because authors provide unstructured content and they have to put that structure in somehow. So our starting point was basically that we had this pre-existing functionality, which was pretty mature code, tested by about 150,000 people who downloaded this application over the years. We had a pretty good test coverage for it, but we had a fairly small engineering team with limited hours to actually do rewrites and no ambitions on reinventing any of this. And in terms of architectural kind of aspects of it, it was fairly cleanly in sort of a foundational library layer of the code base, in that it was spread across several interrelated components in different framework targets, but they were framework targets already. A couple of dependencies to UI layer code, nothing too horrible, and some assumptions of the input coming out of the user rather than, for example, some sort of a command line tool, and some things related to macOS sandboxing that I would rather never think about again. And then finally, we had also created a file format as part of this earlier work. So we had a kind of a spec for what the input to the system should need to be if we isolate it into a service. But we didn't have a validator for this file format. So the project was successful. So it's right now available at pressroom.manuscripts.io. It serves its own documentation over OpenAPI, so Swagger, or in this case, HTML. And there's a GitLab repository up at that URL that you may or may not be able to see. I'll have links at the end. Dan has done a really stellar job actually in documenting a lot of the interfaces for how to use this thing. It's documented on both at the kind of web service level, and the code is actually itself pretty well documented too. So why did we choose Server-Side.swift for this? Well, one engineering thing the solution that it gave us is that we could work a lot more in parallel. So we had some Objective-C to Swift, migration still to do. This code base was old. We wanted to move away from Carthage to Swift Package Manager, also for this same code base, because we still had also the next generation of the Mac client to build out of partly the same code base. And it also allowed us to sort of progressively enhance and modularize our legacy code base instead of building it from scratch. And we went with Vapor specifically because it was just happened to be something we were quite familiar with, both the iOS and macOS engineers in the team. We found it to be quite reliable and complete solution for our needs, and the async programming model that kind of emerged through the project fit our needs very well. And we've been really happy with that part of the choices. Really, the gotchas that we have that I'm going to get to are really not so much in anything kind of Swift and Vapor related. It's actually kind of the real world environment where this has to be built and operated in. But before I get to that, also, I should say that indeed we wanted to build a code base that could then also both live in this web service and also be shoved back into the next generation of the Mac application. So we would have local instances of effectively the same component living inside bundled inside the Mac application as the end result. And what's the use case for that? Offline support. The whole point of having this Mac application still, whilst it's collaborative and works in the browser, is so that people can write for long periods of time when they're offline and have a neat platform integrated experience. So kind of in a way that the Swift and Vapor side of it was just another wrapper for the same components. And one side of kind of unexpected effect that we had from this project is that because we got the prototype up really quickly in some amount of months, we then started kind of getting internal clients in that some of the other parts of this 400-person software company that we were now part of after the acquisition started wanting to use this service as we were developing it further. So we started building up some additional requirements for what other commercial products that they were building needed to be able to do. A really good thing, of course, because if you're writing web service interfaces, it tends to be the second or third consumer that actually really proves that you have any kind of good interfaces that you defined, but also meant that then we would slow down in our abilities to, for example, completely kind of get rid of the Objective-C and do some of the other modernization. So we started responding in some sense to also additional feature requests whilst we were doing this. So the pros of this have proven to be that it's been a kind of a shortcut or springboard for web service development in that we were able to just focus on the new bits in all parts of it. The foundations have been mostly proven solid, and it's worked as a sort of progressive enhancement effort, passively allowing us to identify bugs and areas of improvement in this code base when more and more different kind of consumers have used it. And then we've been able to put back also bug fixes back to the code base that now goes back to the Mac application. And this kind of dream of having the iOS and macOS engineers being able to now build as well as consume REST APIs has proven to be correct for us. Now, the cons are really, like I said, kind of alluded to before, it's not so much about Swift or Vapor in this project so much. It's the fact that it's a legacy code base. 150,000 lines of code will contain some code smells, and it will have assumptions that you didn't really keep in mind in the beginning. So, for example, some of the ugly cases of kind of startup initialization order issues in some part of the code base, or perhaps the difference in if you're driving some of the logic from a UI rather than from a command line tool or a server-side kind of an endpoint, those will hit you. And of course, even if it's a web service, there's some user interface to build to it. So endpoints, HTTP verbs, query parameters, and headers, and documenting this to external consumers becomes a thing that we've had to deal with. And this is more of a kind of a case of putting an experienced iOS developer into a role of a back-end engineer. So there's a learning curve to it, and it'll take some time. And then kind of on the same theme of assumptions, we thought we have a data serialization format that we can just reuse. But then, since we've added things like that code execution feature and a couple of other really cool things in the stack after we built the Mac app, we've realized that there were some holes in the actual data file format and how we'd specified it that needed adaptation. And the solution that we came up with this was that we actually formalized the file format using a JSON schema. So we have a validator for the JSON schema that works in the Swift context, and we also have one that works in the client side, and also actually one that works in the collaborative backend systems that also deal with this data. So having a really formal, good, well-defined serialization formats for like 50 different entity types that we exchange when we're collaborating on these documents has been really essential in improving its quality. And then I guess one thing also that's proven to be unique to this web service use cases of this code base is error reporting. It's quite a different case to provide error reports that are useful and neat in a graphical user interface in a Mac application, as opposed to something that the web service consumers will be able to present in ways that are relevant for them. So being able to make it both robust to some of the errors that can happen, for example, when we're compiling, for example, LaTeX documents with this. We've wanted to put in some optional robustness to error cases that are recoverable, and actually designing interfaces for that in neat ways, and also for the error responses has taken some time. And then finally, purely on the Vapor side, there's been some interesting gotchas as well. Now, one kind of ugly secret in this is that there's still apt-get dependencies in there. We obviously need to get rid of those, but as a starting point, that is what we had. And if you simply try to start up the application like you normally would a Vapor application like this, it's not going to work for the apt-get parts of the code base, which will require there to be a main queue and for you to be, for example, to do timer callbacks or other kind of main queue related things in there. So we've ended up with this little dance to start up a dispatch queue, then asynchronously in that dispatch queue start up the Vapor application, and then spin up the run loop in this specific manner. So that was an interesting one to find. The other side, I guess, is operational. So if you ask anybody whether it's a good idea to run an apt-get application on the cloud, they'll probably have the same answer. And of course, Swift on Linux doesn't include apt-get, it has Foundation, so we had some work to do. So really what we consider the present solution is a workaround. We have some Mac minis running in Phoenix that we're hosting, and that we've managed to load balance, and we set up monitoring, and we've sort of logging for it. but it's all kind of a little bit improvised and a sort of a survival rather than a long-term solution. So yeah, this part of the project is something I kind of like to ignore, that I think that it isn't there, but yeah, it is. It's running on some Mac Minis. The solution to this part is, of course, us further modularizing this code base so that we can get rid of those dependencies and migrating the remaining Objective-C in the Swift. But in conclusion, what we found is that this is a realistic route to building web services, and it's been successful, semi-successful, and we've been able to meet our kind of more business needs at the very least, and we've been quite happy with the code that's come out of it. It's allowed us to use our engineering resources effectively and given us the shortcut for cutting easily 3 to 6 months out of the project at least. Vapor has been very pleasant to work with. I find like I've not really written most of this code, I've just reviewed it. It's readable, it's been robust and reliable and scaled to our needs for the user base that we have, certainly at this stage. And of course, if we had better legacy code, we would have less issues, I guess is the lesson. That fewer apt-get dependencies to port away. And I guess the next question mark in this story is going to be what happens once we do run this on Linux. Because of course, as we heard in the panel yesterday, and as many of us know, there's still foundation level issues that you will encounter when running Swift on the server. So that's what I had. So there's this specific repository that I've been talking about is that URL. If you cut out the last path component out of that, you'll find like 20 other repositories and other layers of the stack that you may be interested to see. And you can sign up at that URL. There's also a Slack channel that we have if you're interested of any of this open source stuff that we're building, where the whole development team is present. So thank you. I take any kind of questions.